Okay, this is scientific notation, so you do get it a lot in the junior cert, and it always you have it if you're doing a science subject. So you have to write numbers as some a by 10 to the power of n. So how do you do it? Well, I'll show you my method for doing it. So here's a number here, 30000. It looks like 30,000, yeah? It says write this as a by 10 to the power of n. Now normally you get this condition here where a is a number less than 10 but greater than or equal to 1. So that means that whatever this number here a is has to be a single digit number, like 1, 2, 3, 4, 5, 6, 7, 8, 9. It can be 1 point something as well, as long as the number doesn't exceed or go negative and it doesn't get bigger than 10, right, or 9.9 specifically, because we can't actually write 10 according to this here. So how do I do it? Well, here's my method for doing it. So let's look at this one, 3, 0, 0, 0, 0. We don't see a decimal point here, but if we had to place a decimal point and not change the value of this number, we would put the decimal point here. Yeah, because 30,000 point something 000 is still 30,000. So yeah, when you don't see a decimal point, you presume the decimal point would exist here at the end. So we now want to bring this all the way back to write it like one number, which looks to be 3 here, by 10 to the something. So it's definitely going to be a 3 multiplied by 10 to the power of what? Well, if we go to the left and hop the decimal point over to just be in front of the 3, so we've done 1, 2, 3, 4. 4 little hops to the left. That's actually a positive now 4 here. So that's 3 by 10 to the 4. And that's it. So 3 by 10 to the 4 is 30,000. So what about something bigger? What about maybe 18 million, say? Okay, so for 18 million, we again know decimal point would exist here. So we want to hop it all the way to the left. 1, 2, 3, 4, 5, 6. Now it can't stop here because it has to be, a has to be between 1 and 10. So if I stopped here, I'd have 18 by 10 to the something. So I have to go one more. Now I'm in here. My numbers are significant. They're 1.8. So I'll use the 1.8. 1.8 is a number between 1 and 10. How many times did I hop over? 1, 2, 3, 4, 5, 6, and 7. So that's 1.8 by 10 to the power of 7. So when you see these powers are positive, we're talking about big numbers. If they're negative, however, we're talking about small numbers. So let's look at what would be negative, right? So what about this? 0.00034. Let's say something like that. Let's say we wanted to write this again where the a is a number between 1 and 10, but now decimal point's at the other side. So let's hop the decimal point this way. So we go 1, 2, 3, 4. We can't stop here, we have 34. 5. So decimal point now comes in here. So I have 3.4 by 10. Now since I went to the right, I went 1, 2, 3, 4, 5. It's actually a minus 5. So it's kind of contravent what you know from the XY coordinates. To go left is negative and to go right is minus. Well, yeah, it still works like that because we have to go to return. We'd have to go to the right and to the left. But what you need to know is if our arrow goes to the right, our little n is negative. If our arrow goes to the left, our little n is positive. So I'll do 1 or 2 more examples here just on a sheet to the side here, and let's say with something like this. So what about we had something like 0.00000016 So we need to write that as a scientific notation. So let's hop the decimal place over. So 1, 2, 3, 4, 5, 6, 7, 8. I can't stop there. That's 1. Yeah, I can actually. Yeah, 1.69. I want a to be less than 10 but greater than or equal to 1. So I'll stop here because that's 1.69. So that's going to be 1.69. Now it's 1, 2, 3, 4, 5, 6, 7, 8. I hopped over 8 times. I went to the right. So that's 10 and n is negative. What was it again? Sorry. 1, 2, 3, 4, 5, 6, 7, 8. So that's minus 8. What about this number? 0.470000000000. So like a massive number here. So like we're a million, we're like a billion there. So we're like 470 billion it looks like. So what would that look like? Well, the decimal point now exists here. So we know it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That gives me 4.7 by 10, and I hop left 11 times, so it's positive. And hopefully that'll solve scientific notation for you. And of course, to work backwards, we have to now bring the decimal point when it's a positive number back to the right to get this number, and back to the left to get that number. Hopefully you'll be able to figure that out yourself.